Solar Weather Report for March 2021. The solar weather report as of March 14th and for the last few weeks show a dynamic and changing sun. We began with a low value of 74 for the Solar Flux Index, or SFI, then it increased up to 81, and currently it's at 78. Recall that the SFI measures the solar flux at a wavelength of 10.7 centimeters and correlates well with the sunspot number S of n. The current numbers show a value of sunspot number of 24. The geomagnetic, or K sub P index, is equal to 3, and the A index shows a value of 7. This last number is a bit high since it averages recent high values of K sub P. Sunspots 2808 and 2809 are currently visible on the solar disk. The ultraviolet or UV rays and X-rays that come from them impact the Earth's ionosphere and ionize gases present in our atmosphere. These processes create free electrons and ions in a layer of charged particles in the ionosphere. A side note, in 1925, E.V. Appleton and M.A.F. Barnett of the UK and G. Bright and M.A. Tuve of the US made measurements of the reflections of vertical electromagnetic pulses that bounced from said charged layer and returned back to Earth. It was Appleton who used the letter E to refer to the downward electric vector that came back. Later, he became aware of another bounce coming from a higher altitude in the ionosphere, and so he named it the F layer, using the next letter after E. Now, when a third layer, this one lower in altitude than the E layer, was found, naturally it was named the layer D. Since no further layers were found below layer D, the letters A, B, and C went unused. Hams know quite well that these layers change from daytime to nighttime since the Earth shields the night ionosphere from solar radiation. In particular, the two components of the F layer, that would be F1 and F2, merge at nighttime into a single F layer. Similarly, layers D and E merge into a single E layer at night. These changes in the ionosphere let us hear AM radio stations from very far away only at night. So it should be apparent that the electron concentration is quite important. So in summary, the electron concentration in our ionosphere is of critical importance for radio communications. The fact that we have free electrons in the ionosphere is directly caused by our nearest star, the Sun. These layers of the ionosphere allow us hams to transmit over very large distances depending on frequency, solar activity, and time of day. Hope you make good contacts. 7-3.